So thanks so much, everyone. It's been a terrific morning. It's funny because a lot of times I try and introduce all these new concepts and things like that about running on the edge and how you do that through Kubernetes and how to extend it. But the convenient part is so many people before me did all the hard work, talking about edge, talking about how complicated it is and so on, yet still explaining how to use the Kubernetes API, which obviously has been very, very successful. My name is Dave Aronchick. I was the first non-founding PM for Kubernetes. I led it for a bunch of years on behalf of Google. Really excited to talk about this platform that we built to really extend these ecosystems into cross-zone, cross-region deployments. I like to start with a somewhat controversial statement, and I basically like to say you're doing infrastructure wrong. Again, I'm not trying to be rude. You're doing it somewhat wrong. And the reason is mostly because folks look at infrastructure as a single concept. Okay, I'm just going to go up to whatever, Google or AWS or whatever, and deploy a whole bunch of infrastructure, VMs, and call it a day. But the fact is that it's so many things, and especially as we get into machine learning, it's the physical stuff, data centers and whatnot, the binaries you put on that physical stuff or virtualized stuff, and then the data. And the more that you can think about these things as a unit, that's incredibly powerful. And the reason I start with this overall thought about your overall stack and what it looks like is because more often than not, you'll see something like this, where you'll have a group, a team ready to deploy some things, and they have their hyperscale cloud. And if you're doing what the hyperscalers tell you to do, you'll be in multiple zones, you'll be using some of their services, but then likely you'll still have on-prem, edge, IoT, things distributed all over the place. And our developer says that looks great. This is an app. I'm ready to roll it out. And your SRE says, GFY, right? And that's because you've thrown it over the edge. Our developer doesn't tell the SRE how to get this out the door in any reasonable way. And the truth is, it's not easy to roll things out, especially as you start to think about things globally. This is a list I posted to Blue Sky. I asked the question, hey, what kind of problems have you seen rolling things out? And this is a short list. Or it just doesn't work for any discernible reason, right? And you have no idea why. Now, when we started this talk, we were talking about things like machine learning. Does this apply? And the answer is yes, absolutely. Models are just applications, and anyone who tells you they are not, is either selling a SaaS endpoint, which most folks don't have to worry about, or lying to you, right? They're overcomplicating it for no reason. It's just an application. You're going to have to roll out these things in the exact same way you do normally. So instead, we say, okay, well, we're not going to do this in a distributed way. We're all going to build a giant machine. But in fact, that doesn't help either. Because the same problems still exist. Even if you have just one machine, the same problems exist, and because you've now chosen a single machine, you've now added your data lake problems on top of it, right? And so before you move your data from the edge into that central machine, you're going to run into problems, and after. And so then you say, okay, but I'm very smart, I know how to roll things out, I'm going to use Bash, right? Bash is amazing. But of course, Bash isn't a problem, and this is where I don't have to go into any of this because all those people earlier today already told you all of these things. What if you have a bad network connection? What if things fall over halfway through? What if you have distributed consensus problems? What if you need to update things atomically? So on and so forth. Tons and tons of problems. Okay, but why are you starting to expand this? Why are people even caring about this? Maybe, all right, I'm going to solve this by having a massive data lake, single deployment, SSH in, call it a day. It's that last bit, data, which tends to be the thing that people are ignoring, and that is one of the things that is the biggest challenge today because it's growing so fast. And all you folks here who are dealing with things on the edge are dealing with this problem right now because the data is growing rapidly and far faster than your network connection is growing. And that means just due to speed of light issues, you are not going to be able to move the data into your central data lake fast enough to start to make intelligent decisions around it. So yes, that is a lot of data. So I like to say there's a modern path here as we talk about machine learning, as we talk about cross-zone, where we take a more data-first approach, where we have a modern path for modern data processing that really looks at cross-zone, cross-region, so on and so forth, and reuses all that infrastructure you've built with Kubernetes and so on. And I call that the modern path for modern data processing. The architecture we like to position is compute over data. The background is my name is the name of my company, is called Expanso. We have an open source platform called Bacalhau. It's a community that's being built around this, and I'll walk you through how this works and how it integrates with Kubernetes. But this architecture, I implore you to think about yourself. How do you move portions of your compute nearby your data, simply because it is more secure, more reliable, and it really addresses what you and your customers need. Compute over data, the reason we called it Bacalhau, like I said, I was there during the naming of Kubernetes. We were trying to come up with a cute name, so we decided Greek was our thing. Now I'm off naming a new thing, and we called it compute over data. We kept abbreviating it as COD, haha, that's funny, we'll have a fish theme. We happen to have been in Portugal when we were coming up with the name, and what is the name for COD in Portuguese? It is Bacalhau. So that's how we came up with the name. It's a funny name, it's impossible to spell, impossible to pronounce, but it's a great project, and I'll show you how we work with it in just a second. And like I said, the company's name is Expanso. So Bacalhau adopts this new architecture. It lets you interact with the network in a way that makes sense to you, via, in this case, the Kubernetes API, but there's lots of other ways to do that. It helps you process your jobs in place without moving your data and limiting your overall leaked information. Now again, that doesn't mean it's exclusively. You'll still probably reuse all of those great tools you already use, but you'll use them in a more intelligent way. Instead of the first step of your processing, using Kubernetes and using cross-zone, cross-region, your first step today is often take everything and jam it into an S3 bucket and then start processing, and that is a disaster. I'm telling you, that is a disaster. Don't do that. Do some form of analysis over your data before you move it, and you will be much, much happier. The key scenarios that we get to here: transforming data before you move it, executing over poor networking, using data in isolation. This is a super short talk. I'm happy to talk to you all about this in much greater detail. But the broad strokes of it are, Bacalhau is an extension and a network on its own that lets you use your applications everywhere, which includes Kubernetes. This is what a job looks like, and it's very convenient that I'm talking to a Kubernetes group, because this looks real similar to a Kubernetes. That is intentional. But it gets even easier than this, and I'll show you how in just a second. And like I said, keep using all of those things, but put Bacalhau before your jobs, and you will have a much better time over with your overall pipeline. And of course, we run in multiple locations, edge, on-prem, low resource devices, but sits in front of your infrastructure. So how does this help you run thousands of Kubernetes jobs? Well, today, you might have your compute cluster, that's great, and you create your Kubernetes job, and that's great. And you take that, you submit it, the scheduler picks a node, and then off it goes. Awesome. How do you do this with Kubernetes and Bacalhau? You add our CRD, and I'll show you how to do this in just a second. It's literally one command. And then you submit your job, and then you tell that where the Bacalhau network is. And the Bacalhau network is distributed, it runs everywhere, it's entirely on-prem, self-hosted. We have a cloud offering as well, but most of our customers and users do want that kind of security and isolation of running their own network. It is nowhere near, I love Kubernetes to death, it is nowhere near as complicated as running Kubernetes. Let me tell you, it is one command to start up and run your node. But then you take, this totally doesn't affect your normal running of Kubernetes. You've added your CRD, it continues to pick a Kubernetes node and go off. But now let's say you want to run a global job. And you say, hey, you know what? I want to run this against a bunch of nodes that may start up, spin down, shut down, whatever they may be. How do I do that? I take it, I submit it to the Kubernetes API server. The API server hands it to the CRD, and the CRD hands it to that network. right? Very, very straightforward stuff. And now it just sits there. And again, that's because you told it to sit there. You said, hey, you know what? I'm going to need to submit to nodes that may come up and down, that may be in multiple locations, whatever it is. You just hold on to that until you find a match for this job. And so now, let's say I spin up a bunch of raw VMs, not even Kubernetes. Though, of course, we do support Kubernetes nodes, but let's say I just want to support raw VMs. We do that. Each node notifies the overall network, hey, you know what, I'm available for these jobs. Please schedule to me, and then you can do that. Again, I'm super short on time, so I won't go through all this, but I'm happy to talk about it after. Let's say you want to add additional compute clusters in multi-zone, in multi-region, no changes to your Kubernetes cluster, no changes to the CRD you already created, right? It's just there waiting for you. And now, if I take lots of jobs and I say, hey, you know what, schedule is all over the place, I hand it to the CRD hands it to the network, and the network places it wherever they're supposed to go. Right? And the whole point here is we understand you've made investments in Kubernetes. We're not trying to replace those things. We just want to help you extend this network into new and interesting ways. Okay, so it wouldn't be KubeCon if I wasn't doing a live demo. Here, you probably don't need to see my email. Where are you? You are here. Okay. Oh, right. Okay, so I've created a very simple dashboard. This is going to run right now. So we have, if I go over here and I get a node list, you're going to see a whole bunch of nodes. And if I do this, grep connected, and I list, you can see I have over 1,000 nodes connected to this. Now, these are simulated. I of course, left my visual aid in my backpack, little Raspberry Pi like this. We simulated that on AWS Spot. Now again, we could actually spin up 1,000. There's nothing preventing us. It's just that was convenient. But you can see here we have over 1,000 nodes, real virtual machines connected to this Bacalhau network, just to show you that it's going up and running. Okay, so what does it look like to deploy? So let's zoom in here just for a second. You can see here the job you saw me running, this right here, each one of these is a sensor running a very, very simple ML model, just to show you that we can deploy these things. And the ML model creates an emoji and sends a color through. Okay? It's very, very simple, but you get the idea. We're just trying to show it working. In order for me to create that job, all I did was this, right? So this is a standard kube command. In fact, we extended it with the CRD to create a Bacalhau job. And then inside that, we named a bunch of constraints that the Bacalhau network is looking for. So in this case, it said deploy to a node called edge, anything that has the edge label, and deploy just in the US region, okay? And so the idea here is to give you first-class constructs. And at the end of the day, it publishes these things, and it's got some other things that we use to do that. Don't worry about that. Again, this is all very application-specific. Let's say I want to deploy to some other regions. How do I do that? Well, I've written some other jobs here where all I do is I'm adding, I took the same spec, but I said, you know what, now I want you to target the Asia region in this particular case. So I'm going to deploy that, and that's it, right? So off it goes. And behind the scenes, it is scheduling these, and scheduling each one of those jobs to each one of the nodes that are part of the network. It takes just a second because we have a bunch of things in the backlog. I'm also going to do the exact same thing against the EU, right? So we have 1,000 nodes, and they're spread all over the world. 350 per region, and they're going to come up and running here in just a second. And so you see there, I'm spinning that out, and each one of those is a brand new deployment to a geographically distributed location. And you saw, I didn't touch Bacalhau at all. I didn't touch a brand new feature. I didn't touch a new network, anything like that. All I did was write that CRD and then spin up these nodes, right? Again, if you were going to try and do this with Kubernetes, which I love, I can't stress enough, you would have to spin up many Kubernetes clusters. You potentially have to have a muxer that spread this between all these various locations, and then ultimately deploy this. And at the end of the day, we're just deploying this through the tools that you already know and love in a network reliable way. Again, I don't have a ton of time, so I will show you one more little feature here. But let's say I wanted to update one of these. I have a second version here that changes the color. And I'm going to do the one for the US, and I'm going to do the one for the EU. We have a bunch of, shoot, sorry, I was doing some debugging earlier. Let me just delete this one to prove to you that it is in fact working. Thank you for your patience, but I hope you will believe me that I say that it is right. Oh, shoot, sorry, I know what I did wrong. In my V2 here, let me just correct this really quickly, sorry. There we go. Okay, so now I've gone and created two new regions, and what you'll see here is, and I don't know if it's coming through clearly, but you can see both in the US and EU regions only, the nodes are changing color. So we updated the model in place, and they are now responding with a different color and a different emoji. Again, it's very small because we have over 1,000 jobs deployed, but trust me, it is true. Actually, I can zoom in here and show you. Right? Each one's getting a new emoji and so on. Okay? So, but the idea is, look, again, I'm rolling out thousands of jobs, and I didn't have to do anything else than just interact with my Kubernetes network against thousands of things. And again, one thing that I'm not able to highlight here, again, just because of time, is we have a whole schema for how to queue and how to do attachment, detachment, particularly relevant for edge folks. Because as you know, networking inherently is unreliable. And that's what we're designed to solve for. Okay, so that's the demo. We have lots more. Please find me after. I'm happy to walk through or answer any questions. What else can I use this for? One thing we get a lot is around the concept of a distributed data warehouse. Again, very relevant to folks in this crowd, where you have all these IoT or retail or manufacturing, edge devices, defense, planes, trains, automobiles, you name it. The IoT data is often very poorly structured. Often you have very unreliable connectivity. And the worst is that even if neither of those was the case, you can't start to take action until all that data gets into your warehouse and through your pipeline. And what you want to do is start to take action as soon as you know, right? Trigger an alert. Let me know something. Tell me what's going on. What you're able to do with us is put Expanso, put all those devices that I was showing you earlier near, like either on the IoT devices, but more often than not, IoT devices are quite locked down, or near. And this is a concept we call near compute, where it's the idea like I can put an iceberg table there, I can start collecting data, and I can process a portion of my ETL out there. I'm not saying remove it. I'm not even saying change your ETL at all, other than take a portion that you've already run and run it in that distant location. This reduces storage costs, it speeds ingestion, all that kind of good stuff. And the best part is it enables your data scientists to be much more responsive to their needs in the market. So now she can say, you know what, I'd like to ask an ad hoc query to everything. How do I do that? You can do that in this exact same way that we flow data in, you can flow messaging and queries out. And she's able to do that without moving a byte. So, and again, in particularly in secure situations where you want to be thoughtful about what you move, you can do that. Optimized data pipelines, this is another one. Again, nothing against the Splunks and the Databricks and the Snowflakes and the Datadogs of the world. They're fantastic. But like the idea that the first step is I'm going to take all this raw data and move it into a location, that's just not a good pattern. The better path is, and that's because it's very expensive, it's often very insecure. This is what the log4j bug was about, like moving all this raw data in unprocessed. It's also extremely expensive when you do that. If you're able to do some initial processing, in this case on those servers using an agent, you're able to reduce the amount of logs that you move in. Again, doesn't change your pipeline, you're just moving portions out, and then everything just gets faster. And, by the way, it also gives you a path to storing things in an archival way, in a way that makes sense for your business. Whereas previously, you had to move it into your very rich central location before you could move it off to store. And then securing data, customer data. Here we are in GDPR. It is remarkable how little most people know about GDPR. For example, I am not a lawyer, but we were told by lawyers that even moving raw IP addresses could be a violation of GDPR, right? And so you have to, again, I'm not a lawyer, go talk to your own, but theoretically you need to remove that last octet before you move it off the device. And obviously most people don't. So the suggestion is instead, do processing near where those devices are in the same region, same location, and you can make a much cleaner overall compliance. And by the way, give you an audit log of all those jobs you did that you can hand to your compliance team. So, like I said, we love Kubernetes. That Kubernetes CRD, you roll it out, and then it just magically works. And I am telling you, as someone who has been in this game for a long time, like I was shocked how magically it does feel. You can go check that out there at the QR code or talk to me after. There are lots of other ways to run this. For example, what you saw here those were WASM jobs running, but we support Docker, obviously, we support sed, we support Java. Like, we haven't found a pluggable executor that doesn't work, and that could be completely custom to your business. And we always get the question, well, I'm entirely on-prem, what do you require? Do you show up? Nope, just, anything you saw running here can run on a generic x86, ARM VM, anything that we run a binary on. Our agent is extremely small. It can run, like I said, on a Raspberry Pi device all the way up to an 8 GPU machine. What you choose to execute against that is yours. No new SDKs, no new changing your languages. As long as your thing can be containerized or deployed or whatever, you can run with us. So, summary. Compute over data, it's an old new thing. Like, honestly, the number of times people are like, I kind of implemented a solution like this at my last job or at my university or so on. Very common. Our hope with this project is that you don't have to go and re-implement this, that either in the open source project or working with us commercially, we can get there. But moving to compute over data is a very good thing. Please do it. Use the Kubernetes API you know and love. I didn't have a chance to show you, but like everything you see here is wired up with Prometheus and all the natural native logging and open telemetry and things like that. All the things you're doing with Kubernetes still flow through. It just magically, like I said, makes your overall deployment much, much more flexible. And those kind of flexible architectures that meet your users, your customers, your IT department, where they are, rather than asking them to adopt a new platform, that really is our core philosophy. And if what you're seeing here doesn't map to that, please come talk to me because I would love to help. Bacalhau is open, completely open source. Nothing you saw here is behind a paywall. Just so you know, the code is open source. The binaries are commercial. But if you want to download and fork it and compile it and run it yourself, enjoy. We would love to have you as part of the community. And obviously, we have tons of people on our Slack channels, quarterly releases, and so on. And with that, that is basically it. I have a minute left. If anyone has any questions? Yeah. Oh, sorry. Go ahead.
I was wondering, where is Bacalhau control plane hosted? Like how the agents are communicating from the edge and how they're getting those jobs?
Yeah, so there is an orchestrator that is self-hosted. You just pick a machine and say you're the orchestrator, and then magically it just kind of happens. Each node, unlike Kubernetes, and again, there are different ways to deploy, and I'm not bad-mouthing anyone who did these centralized architectures, but each node makes the network aware of what its resources are at any given heartbeat, right? So instead of Kubernetes, or any of the centralized architectures that maintain a central order book, the node will say, oh, here's a new job coming in. I am a placement for that job. Like, come place it with me. And then the orchestrator or the control plane will say, all right, everyone notified me. Like I said, there was a new job. Everyone notified me what was going on. and I'm picking this one arbitrarily as the fit for that job. So it's a little bit more chatty in job placement, but that's because we simply don't know what's available at any given time because of the support for network connectivity and disconnection. Does that answer your question? It doesn't. It's up to you what a node notifies about. But other than just the heartbeat, there's no broadcasting. The node simply, when it connects, it says this is my status as a node. And then when it heartbeats, it'll say, hey, you know what? I have this many CPUs free, or I have this much time free, or whatever. Heartbeats are on about a 30-second basis right now. But again, it's totally configurable. But it doesn't broadcast to everyone. It just broadcasts to whoever identified itself as the orchestrator node. Does that make sense? I think there was another question over there. Oh. All right.
Okay,
yeah.
so many thanks for the talk. What I was wondering about is in your examples, you showed us classical selectors or a region or something like that. But this is very data-centered or centric. So would it be also possible to have some data catalog implemented that I say, okay, I don't care if it's Europe or Asia or whatever, I just care about the data type itself, which is necessary.
That's one of the core reasons we got started. So one of the things that we found is people need a data as a scheduling construct, right? So whether or not it's this node has access to this mount or this particular content addressed ID or, I don't know, any label you'd like, you can place it according to that rather than saying this is the characterization of the node itself. That is native to the job, absolutely. Okay. Does that answer your question?
Yep, many thanks.
All right, I think I'm out of time. I'm happy to be here, and come visit us at the Intel booth. We're doing a bunch of demos there around machine learning and video, processing video before you move it. So you can come check out those demos, and of course I'm here all week. So thank you so much.